Alright, let's look over this theorem and this definition here. First of all, this theorem, the existence of a limit. Okay, and really we talked about this already. This is just formally stating this. So it says let f be a function. So let f be a function. We'll call it f of x. And let c and l be real numbers. So here is c and here is l. The limit of f of x as x approaches c is L if and only if. So this right here is true if and only if you have the existence of this limit and this limit. And these are both one-sided limits. So this is saying the limit of f of x as x approaches c from the left, if that equals L. Also, if you have the limit of f of x as x approaches c from the right, if that also equals L, then you can conclude that the limit of f of x as x approaches c is equal to L. Okay? And this diagram over here illustrates this. Okay? So, this here in the light blue, this is showing you when the limit of f of x as c, or I'm sorry, of x is approaching c coming from the left. And you can see when x is approaching c coming from the left, that's going to be equal to L. Okay? These dark blue arrows here, this is representing the limit of f of x as x approaches c coming from the right. It's coming from the right. That's also equal to L. If you have both of those one-sided limits, they both equal L, whatever L stands for, then you conclude overall the limit as x approaches c is equal to L. So that's just the idea of one-sided limits here. We've talked about that before. I think we have a pretty good grasp of that. This other thing, this definition of continuity on a closed interval, we haven't talked about this a whole lot. So hopefully you know the difference between a closed interval. Okay, a closed interval would be like from A to B. Okay, where an open interval would be from A to B like this. Okay, so that's the difference between closed and open. We're looking at a function f is continuous on a closed interval from A to B when f is continuous on an open interval, A to B, and the limit of f of x as x approaches a from the right is equal to f of a, and the limit of f of x as x approaches b from the left is equal to f of b. If we have that, okay, then the function is continuous from the right at a and continuous from the left. All right? So if we look at this function here, okay, first of all, it should make sense that looking at this function, it is continuous on the open interval from A to B, right? Then, if we look at this point here, if we took the limit of this function as x approaches a coming from the right, does it make sense that that would equal f of a? Okay. And then if we look at this point here, if we take the limit of this function as x approaches b, coming from the left, that's going to end up being f of b. Okay? Which, that's the definition of continuity on a closed interval.